In this lesson we're going to learn about the conjugate root theorem. The conjugate root theorem is the last piece of theory really that we need to learn before we can start factorizing some fairly extensive polynomials. So the conjugate root theorem states that if a polynomial has real coefficients, and you remember that at the start of this section on factorizing polynomials, we talked about polynomials that were over R or over C. So what we're saying here is that a polynomial that's over R, it has real coefficients. If a polynomial has real coefficients, then its complex roots occur in conjugate pairs. Now, just a reminder what a conjugate is. If Z equals 3 plus I, then the conjugate of that, Z bar, Z conjugate, is 3 minus I. So let's just look back at a problem we did previously when we were completing the square. Take this one here. This is a polynomial. It's a quadratic, it's a simple polynomial. But here are its factors. Notice its factors are Z plus 2 minus 3i and Z plus 2 plus 3i. How are they different? The only way they're different is that this is a minus 3i, this is a plus 3i. These are conjugates. The polynomial had real coefficients, therefore the roots or the factors occur in conjugate pairs. Okay. We will use that when we get to some more difficult problems, so just tuck that away in your mind. But before we go on, I just want to make the distinction between what's the difference between a factor and a root. What's the difference between a factor and a root? Let's go back to one of those earlier questions we did. Pz was equal to z squared minus z minus 6, I think it was, and we factorized that and we got z take away 3 and z plus 2. Okay, these are factors. So z minus 3 is a factor, z plus 2 is a factor. However, you remember that we said P of 3 was equal to 0. If we subbed in 3, we'd get 3 squared is 9, minus 3 minus 6 is actually 0. Or we could sub it in here, and you'd very quickly see 3 minus 3 gives you 0, so multiply it out, you get nothing. P of 3 equals 0. That is, we let Z equal 3, i.e., Z equals 3 is a root. Sometimes it's also called a 0. Okay, now a bit of quick revision here on some of your earlier maths. So Z equals 3 is a root. Z minus 3 is the factor. Make that distinction. Z equals 3 is the root, Z minus 3 is a factor. Now, if we went back to some of the earlier work we did, you would have done in maths, if you were actually sketching this polynomial here, if you were to find the x-intercepts, say this was y equals Okay, to find the x-intercepts, you'd let y equal 0. In other words, you'd make a 0 there. And you'd get z minus 3 times z plus 2 equals 0. Therefore, you would have said z minus 3 equals 0, or z plus 2 equals 0. And then you would have said, therefore, z equals 3, or z equals negative, z equals negative 2. Okay, so z would equal 3, 1, 2, 3. This is your z-axis, this would be your y-axis. Z equals 3, or z equals negative 2. And what you would find is that you had a graph that looked like that. Okay, notice here that 3 is called a root. Z equals 3 is a root. I remember that because if you imagine this is a tree, this is ground level, then where it goes into the ground is a root. That's just my silly way of remembering it. And here's another root because that's where this part of the tree goes into the ground. Okay, so the point that the value of z that you sub in that gives you 0 is called a root. But the factor is z minus that number. Okay, so z minus 3 is the factor, z equals 3 is the root. Important distinction to make with polynomials and their factors. Right, the next lesson we're going to be looking at how do we factorize some degree 3 and or some degree 4 polynomials. So we'll try and put a lot of this theory that we've been learning all in together to be useful.